So this is going to be easy and correct high availability PostgreSQL with Kubernetes. How many of you here are actually actively working with Kubernetes in your enterprise right now? That is about how many I thought I would get, which is way less than even a third of the room, which is good, for given how I prep my deck. How many of you have actually used containers, like Docker containers or some other container? Actually used them, not just read something, but actually used them. Okay, that's more in the room. Good. So then when I hit the container part, so I'm going to do an intro all the way from containers up and why they're awesome. Okay, and then, but don't get so upset. He's like, fuck, I just showed up for this session and all I'm going to get is slides. Most of this talk is demo, but I can't really talk about why the demo is cool unless you understand why containers and Kubernetes is a good thing. So I give permission. Raise your hand again who's used Kubernetes. And don't raise your hand just because I said the word permission. OK, those people have permission to not look at me and at their laptop. No YouTubing, just like lightweight email or something, OK, when I'm giving the intro sections, even though I'm hotspotting rather than using the conference Wi-Fi. All right, this is me. This is the company I work for. We have a booth downstairs, so if you want to hear about all the great things we do, our business model is Red Hat of Postgres, basically. So if you understand the Red Hat business model, that's our business model. We're Postgres people, hence why we're here. And that's where you can find me. And that's a 0 because I'm neat like that. Okay? Let's get going. The agenda. Talk DevOps and Kube a little, and then demo. A little. Stop looking so upset. All right, rules. Ask questions. I like my questions during the session rather than at the end. The only thing that may happen is if I find that I'm running low on time, I may say, great question, but let me take that at the end, or I can't go into that right now. Let's talk about it after. The only other caveat, though, is I have a flight very soon after my talk is done, so unfortunately I won't be able to take any after questions. No, I can take some, but you can always find me at the Steve Zero. And then the other thing is to have fun. Right? And I'm a very informal speaker, so please I'll pick on some people in the audience a little bit if I know that you're kind of good-natured, like Joe and Sarah. They're definitely going to come in for some. But then I know some other people like a Chewy who I love, so I can't pick on them too much because they do good things for my dog. OK, so what does it take for running a database in the enterprise? I'll go through these relatively quick, but I want to hit some of these points. The bulleting order is wrong. There's provisioning, right? So there's create, destroy, all that good stuff, provisioning the database. The bullets are in the wrong order. So high availability is something that you care about, right? In the enterprise, you want high availability. You want uptime, failover management. You want disaster recovery. Not that it ever happens to any of my databases, but it might happen to some of yours, that you might have a disaster and you want to recover from them. Monitoring, you want to be able to check things to see if disaster is coming and maybe avert it, right? So, but how do you make this reliable and maintainable? Almost all of you are doing that now today, right? Or your goal is to have all of this stuff being done today, right? Are most of you doing almost all that today? For those of you not using Kubernetes, how do you do that? A whole bunch of things kind of cobbled together, or not cobbled, strategically chosen for their capabilities, and then put together with some sort of duct tape and baling string kind of thing. Maybe using Ansible, maybe using something else to deploy and do that stuff. But automation, and each of them has their own special, unique snowflake way of being installed. You need to write some sort of special glue. You're learning unique things for each part that you're doing. And I'm going to show how we can get that to be more reliable and more maintainable. And this is where we're going to talk about the Crunchy's Postgres operator. But to get to the operator, I have to talk about what it is. It uses containers, right? So we've made a whole bunch of containers about not just Postgres itself, but basically the whole ecosystem, or not the whole ecosystem, but a lot of the pieces in the ecosystem, right, inside of around Postgres. And then we've put that together to make an operator. And how many know what an operator is in Kubernetes? Like even less than the people who are using Kubernetes. So an operator is a way to kind of bundle things together and make it smart, and I'll talk about it in a little bit. Okay? So we put those together, and all this stuff is open source, GitHub/Crunchy data, and you can see all the bits that I'm showing today. Why Kubernetes? So I'm going to start with why Kubernetes. It's the level of abstraction where you really want to be working. So what I mean by this is most of you really are probably right now, if you're cobbling things together, you're working at the level of the OS. Right? And you're worrying about file handles, and you're working about a whole bunch of other things that you actually care about, but only because you're being forced to care about. Not because it's something that you're like, well, maybe for some of you, you really nerd out on that really low-level stuff, but in the most part, you care about making your databases performant and up and reliable. And you're learning that other stuff because you have to go down to that level of abstraction to get what you want. Does that make sense? And Kubernetes allows us to actually orchestrate and schedule and maintain things at the level we want, which is like the database tier and up. So I'm going to start with containers, because this is part of what Kubernetes uses. Kubernetes is all about orchestrating and scheduling containers. There is this thing called KubeVirt, which is for also virtual machines, but I'm not going to talk about that. So we're going to talk about containers. And I'm only going to talk about the part about containers that makes it important to us. So what is important about containers? One, they're immutable images. Right? I cannot make a change to the image that is used to spin up a container without recompiling the container. So if I give you a container image and you spin it up, it's going to be exactly the same as if I spin up the one with the exact same hash mark. So what does that mean? Some developer that you accidentally gave permissions to that container went in, changed the configuration, screwed everything up. How do you actually fix it? You just restart the container, and it's set back to exactly the way it is. I need 17 instances of that exact same container. What do? I just spin it up 17 times. And it's going to be, I'm guaranteed it's going to be the exact same thing all 17 times. Right? Containers also deliver the bits. Right? So just like an RPM or what's yums? I mean, not yums. What's apt-get? A deb. Right? Just like an RPM or a deb or an MSI, you get the bits. Right? That's cool. But you also get the configuration. Configured to run is what I mean, not just configuration files. You don't just get a PostgresConf. Everybody gets a PostgresConf when they install Postgres. But this is the expert, the person who knew how to make that container, hopefully it's an expert making that container, actually set up the PostgresConf the way you wanted it to be. And may give you the ability to put a new one in, but it's already set, ready to run. And this is the important part with the containers. It's ready to run. It's set up so that I can say Docker run or cryo run, and it spins up the container running. Not install the bits, go to the configuration files, check your this, that, it goes. Right? And this is, so Dan Walsh, one of the people who works at Red Hat, one of the people that put SE Linux into Linux. When I was at the first DockerCon with him, he was not excited about anything else except for this part, because RPMs are an insufficient solution. He's like, now we can finally deliver the software actually the way the user wants, not just the bits, but actually most just want Apache to run. They don't care about all the rest of the stuff. So that's the cool part about the containers. And they're easy to extend. So if almost every one of you said you've worked with containers, you know that you can make a container, the first line of a Docker file is from. So the expert can build the lower layers. Like we at Crunchy, when we make our containers, they're all straight from Red Hat. We don't go ahead and build our own OS containers. We start right from there. We say from that CentOS image, layer these other things on top. And then for some of them, we say from one of our other images that we built, layer on top of that to make this other image. And why this is awesome is because the experts at the layers can build those layers, and then everybody gets to consume it. And I don't have to worry about it. And when Red Hat fixes a bug, I just rebuild my container, and I'm done. I don't have to do any fixing of my container. I just rebuild, and I get the new container. Make sense? So I think those are the important parts about this. Gets us to maintainability. This also gets us to, and I know I have a slide on it later, but I'm going to give the punchline now. I learned this from my therapist. As a divorced man, now engaged, this is a very important life lesson that no matter what else you learn today, you should retain this one. Ready? Clear boundaries, infinite possibilities. And everybody's like, what does that mean? And that's what I said to my therapist too. But what it actually means when you think about it is, most of the times when fights occur, when things go wrong, and this is definitely true in companies, it's because there's not a clear boundary about who's responsible for what. Two groups think they own this area, or they're the expert in this area, or whatever, and because of that, they spend a lot of time with friction at that boundary area. So if you make the boundary really clear, then it becomes, I can do whatever I want on this side of the boundary because that's none of your concern, and this side can say, I can do whatever I want on this side of the boundary because it's none of your concern. So there's none of that friction about who's doing this. And containers do this because you can have your OS people and your systems administrators making the base layers for your containers, your DBAs making the database layers, and your app dev saying, I'm just going to put some other extension, and that's all I'm going to add on top. I don't get to mess with the other things. So containers are the beginnings of our separations of concern. Okay? So I call Kubernetes the new operating system. It's definitely, some people call it the cloud operating system. I think for most people, it's the way we're going to conceptualize operating systems in the future. Out of the box, it's ready for distributed architecture. Right? Most of us are moving. Are most of you moving or already have moved to a distributed architecture? This is really simple. It's like two-syllable words, one-syllable words that you can either say one or the other, yes or no. And most people can handle that by the time they're like 1.5. So are most of you moving to a distributed architecture? Yes. Thank you. I would think that most are, right? So rather than having to learn how to do all that plumbing, this assumes you're going to be distributed and has a lot of it built in. It's got things like persistent volumes and persistent volume claims. And I'm bringing these terms up in specifics because they become important later. Persistent volumes and persistent volume claims is the way that Kubernetes handles allowing a container to attach to storage that's not local to the container. Right? When you're spinning up containers somewhere, anywhere on a cluster of machines, you don't want the storage to be local to the node that it's starting up in. You wanted some storage that I can move that container around, and it can always reattach to the same storage. And that's what a persistent volume allows you to do. And then when the pod actually grabs the storage, that's a claim. So persistent volume is network storage, not exactly like a big NAS device, but NAS devices can be that. And then the claim is when the actual container grabs the storage. Make sense? Good? Yeah? Okay. You're like my barometer for like how the whole session is. A lot is on your shoulders, dude. With great power comes great responsibility. Deployments. So deployments in Kubernetes allows for automated rollouts and deployments and rollbacks, rollouts and replication. So instead of having to do things like a big Ansible playbook, if you're lucky, or something else like that, you just say deploy this container, and it handles all the architecture of spinning it up. If you say I want 3 of them, it'll spin up the extra ones. It'll make sure all 3 of those are running. It can do things like, it can do those staggered, like, what am I thinking of? What's a staggered? A rolling deployment, right? You can configure it to do rolling deployments without automatically, right? It's kind of built into the architecture that it's a distributed cloud architecture, and this is how things are done, right? So we'll be touching on deployments as well. It has built-in services. So in a distributed architecture, you have services talking to each other. And rather than having containers talk directly to containers, for those of you who've used containers, have you spun up 2 trying to talk to each other? Yeah, how much fun was that? How about when you move to 3 or 4, right? Like you've got a database, a caching layer, and an app server. It starts to get really unwieldy because you're trying to talk directly to containers. What services do is it says, I'm going to be the proxy and load balance below all those containers underneath. So if you want to talk to the replicas of this database, you talk to the replica service. The replica service knows all of the replicas it's talking to, but you as the person talking to the service never need to care. Just talk to my IP, and I'll take care of the rest underneath. And services, their IP address is guaranteed for the life of the cluster. Their name and IP is guaranteed for the life of the cluster. And I bring this up because we're going to take advantage of this as well. And it can also handle things like ingress and routing. So for those of you who spun up containers also, especially if it wasn't just on your laptop, how much fun was it trying to get that container to be talking to the outside world? Yeah, not fun, right? And so built into Kubernetes is the ability to say this URL points to this service, which then points to these containers underneath. And you can put Nginx in there or HA proxy. It's built pluggable that way. If you already have a software-defined network or you have some Cisco router and you're like, or load balancer, and you're like, I'm not ditching that hardware. You can actually plug that in directly into Cisco, and it'll handle that as well. Okay? So these are some of the things I'm going to take advantage of today. The other part that it brings is declarative configuration. Do you know what I mean when I say that? Basically, you define your whole configuration in a YAML file. It's not running a bunch of commands. You say, this is what I want the desired end state of this thing to be. So in the file, you'll say, I want these services stood up. I want these pods stood up. I want services in front of them. I want this ingress. I want that. You feed that declaration to the cluster, and the cluster says, OK, that's the truth. And then the cluster takes care of, I'm going to make the world match the truth. Right? So you basically just feed it all in, and you let it go, and it's asynchronous. And then when the world doesn't actually match the truth, the cluster knows, uh-oh, something's wrong. I better go fix the cluster. Okay? Which this is nice, because rather than having a command, like sending, here's the Google Doc, that's all the commands you should run to make this thing run, and you forget a flag or something, you can just pass that declaration, and as long as the clusters have the same software on them, it should just work. So it's very easy to move from a developer machine to a production machine. The flow I actually like more is set up the production machine the way you want, feed that declaration back to the developers on a lower powered machines, and then developers are actually working on the same exact configuration that they would be running in production. Passwords are different and all that other stuff, but it's no more of this stub this out, stub that out, and assume you have this, and then set up your own usernames and passwords and all that other stuff. It's exactly the same, which is really important in microservices. It's written in YAML or JSON. Helm is another great way of packaging those things up. Ansible, you can actually, for those of you already using Ansible, you can use Ansible to declare stuff as well. And this is the other part that I think, this is the last part I think on Kubernetes. You install and configure software in a consistent manner. Me read pretty English one day. The idea here is, remember when I was saying you were cobbling things together now? So like you install RPMs for Postgres, and then you may build from source from Prometheus or something else, and there's all these different ways and networking things and funky files you do for like hooking it up to services and stuff like that. In here, once you learn the pattern of how to deploy software or how to deploy containers, everything gets deployed the same way. It's the same consistent declarative pattern over and over again. It's up to the container makers to make sure that they fit with that pattern. It's not up to you to figure out how to glue that together. And so this is, again, you're at the level of abstraction you really want to be at. I don't want to become an expert in how to install Apache. I want to become an expert at how I get Apache running and serving up my stuff as quickly as possible and as securely as possible. So I let the Apache experts do that. They give me the container. I drop it in Kubernetes. I go to the beach. I tell my boss it took 2 weeks to actually get it running. So operators are on top of it. And I'm going to go through this relatively quickly just because I want to stay on time. Operators is the new way of packaging things in Kubernetes. They're actually about 3 years old, but the real taking them on by the Cloud Native Compute Foundation is only within the last year to year and a half. It basically allows for, in the same way, you know, extensions in Postgres? I'm assuming in this audience that would be a safe. So it's basically allows that same kind of mechanism for Kubernetes. We have I don't remember if I put the slides in for that. Yeah, I didn't, because I'll just talk through it. There's resources and controllers inside that do things inside of Kubernetes that are default, like a service. That's a resource. The deployment, that's a resource. And then there's controllers that operate on them. Those are default objects built into Kubernetes. What operators allow you to do is define your own resources and your own controllers and just install it into Kubernetes. Right? Because almost everything inside of Postgres is a function. Right? And so this is the same kind of idea, like, OK, well, write your own functions, package it up, put it into an extension, and you're good. So that's what the operator is allowing you to do. It's called they use a custom resource definition, CRD. You ever see that? So the nice part about here is it's for packaging up whole applications that have intelligence inside of them as opposed to just a service. It's not that big a deal to stand up one Postgres. Here's a container, run it. Standing up an HA Postgres that has automatic failover, that knows how, like, if the master goes down, what to do, how long to wait so I don't get split brain, all that kind of stuff. That's not easy to do with just a single container. And so that's what we did in putting this all together as an operator. Having the operator framework in place, for those of you who used Kubernetes before, this used to be a stateful set. But we've moved to the operator framework because it allows us a lot more flexibility and a lot more power in terms of enabling the kind of things that most of you are going to want to do. Okay? So that's what I just kind of said. Handle failover, multi-resource creation. So sometimes you spin stuff up, you want 3 things at once, not just one set of containers. Backup and restore, upgrade. So we can do upgrades, right, with a command, single command. So there's my slide again. Remember, take this home. I'm telling you, it helps at work, it helps at home, it helps in all sorts of places. Clear boundaries, infinite possibilities. Confusing statement to start with, life lesson. Okay. Demo time. So that's all the slides. Is that okay with you? Or do you want more slides? You're okay? Good. Okay. So I'm running, so there's I'll leave that at wrap up. I am running Red Hat. I used to be at Red Hat. So I'm running Red Hat's distribution of Kubernetes. It's called OpenShift, right? But it's just it's their distribution. It's like a distribution of Linux. This is a distribution of Kubernetes. All the same operations I'm doing here, you could do it on a raw Kubernetes cluster. It's just OpenShift has a very nice user console, so it makes it very easy for me to show you things that are harder to visualize at the command line. Okay? Okay. So the first thing, so the thing I did behind the scenes before we got here is I installed the operator. Right? So I installed our operator. It's a collection of containers. I'm going to use, I know for the Kubernetes experts in the room, you know that I'm misspeaking when I say that a pod is the same thing as a container. I know that, you know that, but it's easier for this audience where not many people know Kubernetes to just have them assume it's a container, okay? Know in real life, but gloss over this if your brain is getting full. A pod is one or more containers running together, okay? But that's not important for today's discussion. It's easier just to think in terms of containers since that's what you already know. But what? And don't call me Shirley. And don't tell any Kubernetes experts that I said a pod was equal to a container. That is not factually true. It's metaphorically true. Okay? And it's on tape somewhere here. All right. So we have a container. This pod, actually, this is a place where the pod I'll show you that it's running multiple containers. Right? This is the operator. And if I look at it's actually running, oops, too fast. It's actually running a container for the app server. It's running a container for the eventing service. There's a whole bunch of containers in this pod that I'm now going to start interacting with. You could, if you want to, remember how I said you can do ingressing and all the way in? This is just going to talk over 8443. I could, if I want to, make a route to this pod that would allow me to just use web commands as long as I move the certificates around. But I generally don't like administrative things exposed to the outside world, even if it's like password secured with SSL. So there's this nice thing that I can do here and this is where I'm going to start pulling out a script because no one enjoys watching typos. Okay, so the first thing I'm going to do is I am going to it sounds like I'm not logged in. Yeah, I'm not logged in. All right. Let me log it back. I logged in like when I was sitting in the last session, but I must have hit. Don't memorize that token. Erase it from the video. Okay, now we're back in. All right, so now I can do that command line again. Yes, good. And I'm going to do, so what I'm doing here is I'm telling OpenShift command line, so this is the I want to port forward into namespace my namespace / project PGO, talk to the Postgres operator, and port forward 8443 on the operator to that pod I showed you to 8443 on this machine. Cool? Okay. Because I don't want you to think I'm doing any kind of hidden magic here. This is all the same stuff you would do it when you were at home. All right, so now we're all set because now I can talk to the operator using the PGO command line. So for our operator, we have a command line. So all I've done is installed it and made sure it's running. From here on out, I'll show you, we're going to work in the namespace, or what you could think of as project. In OpenShift, it's called a project, is PostgresOpen. And what's in there? Nothing. Empty. Nothing behind my hands, nothing up my sleeves. That's why I wore a short sleeve shirt. All right, so the first thing we're going to do is the most simplest thing you're probably going to want to do is I'll do the command and then I'll explain what I did. So I am creating a cluster. I say create a cluster. I want 2 replicas. So this is going to start up a master with 2 read replicas on it and make it in the namespace PostgresOpen. Good? And and call the cluster cluster1. Here we go. So that it should be done by now. Or it's in the process of working. So in OpenShift, gray like this usually means I'm pulling the container down or I'm doing something with the container. Light blue means I've got the container and I've got it running, but I'm not routing anything to it. It's not fully deployed yet. And then dark blue like this means it's deployed and running. Does that mean Postgres is already up once it's deployed and running? This is a trick for all the container people. No. But thanks for being brave. No, because all the container means is I've started the container. It doesn't mean anything inside of it is actually up and ready and running. What it means, but here, if it turns dark blue, that means it's ready. Because we've put health checks. One of the things that Kubernetes does out of the box is health checks. And we've written health checks into our container operator, which says, don't start routing things or don't consider this live and healthy until the Postgres server responds back with, I try to connect, I connect, and I'm done. So until I can actually connect to the database, it automatically behind the scenes is trying to connect to the database. And until it can connect to the database, it will be in that light blue state. Right? So this is one of those things that Kubernetes gives you out of the box. There's no health, you don't have to write the health checks. We gave it to you. And Kubernetes does it automatically. All right, so everything's up. This is the master. These are the replicas. You can tell they're replicas right now in this original state because they've got cluster1 dash some name after them. Make sense? And this, we made a backrest shared repos to have storage space in case we do a PG backup. Any questions so far? Okay. Everyone believes this is just working? You guys are I'll have my salespeople contact all of you. All right. So the first thing I'm going to do, because I never trust it, is I'm actually going to go in and put data in the database. So OpenShift has this nice web terminal where I'm actually now inside the running pod, the database pod. It's an SSH, basically an SSH session in. So I'm going to say PSQL workshop. By default, we turn on trust localhost, right? So you have to, if you're in the container, if someone's in your container, life is way worse than them being able to log into PSQL. Just letting you know, okay? So I'm going to do, now, no one likes me also putting typos in DDL statements. So I'm going to actually paste text and age int. I actually don't feel like being completely honest today, so maybe I'll change this value before I put it in. I just did that imposter. No, actually, I did that imposter syndrome session. I'll be fine with my age. So there, I put my age in. I inserted a value into the database. Everybody good? So we can do, let me scroll down a little. So this is, there we go. Maybe you didn't know this. Table test returns all the values in your table. So there we go. I put data in the database. Everybody believe that? Yeah, that's an easy one. Okay, no, you still don't believe there's data in the database after I did that? Well, forget it then. Okay, so what should happen? What should be done by now? Where should I be able to do? Exactly. Bonus. Not as brave because he took the risk. That was a riskier question that he said yes to. So let's go to the pods. Okay, so actually I'm going to do it from the overview because it's easier for me to see. Here's a replica. I'm going to go into that pod again. I'm going to go into open a terminal. PSQL workshop. I did say workshop on the last one, right? Table test. I've forgotten to do that and it ends up in the public and Postgres database. And there we go. Okay, so are most of you DBAs? Is that a yes? Shake hands, raise. Who's a DBA? Raise your hand. Who's a DBA because there's no other DBAs, and so they got allotted the task of being the DBA? Yeah, okay. So that's about more than half the room. So how many of those people, I'm sure DBAs, you love learning about how to set up replication. That's you love that stuff. Just like developers love learning about how to write regexes and stuff like that. So how many of those other people, how many of you have ever tried to set up replication? And how much fun was it to learn and set up replication? It was vomitous reaction, right? So here's the benefit of what I just demonstrated. You had container experts and Postgres experts at Crunchy set up some containers. You had Kubernetes set up the whole infrastructure, and with one command, I set up a replicated database, right? Now, I'm assuming the guy in the back with the MacBook and the big hair is a developer, because he looks kind of scruffy like me with the beard and everything. Are you a developer? Yeah. Brilliant. So, DBAs, we can bridge, given that we're in tech, bald guys can kind of bridge every demographic, just saying. So the thing is, now this is the question for the DBAs. Would you like in a perfect world, you have infinite money and resources, it's not about servers and stuff, would you want your developers actually starting with a replicated cluster when they were doing the development work? Would you like them building and testing against a replicated cluster? DBAs, yes or no? Yeah, you wouldn't? Why? This is interesting to me. That's I would ask them why they need to access the replica. Because for reads. So suppose they were doing writes and reads. Yeah, so because, and I don't want, and okay, now DBAs, how many of you want those developers actually setting up replication themselves? None of you, right? But what the operator allows is you can actually install the operator like this, and then 15 minutes, ta-cha! So what you can do is install the operator like this and give developers access to this in a Kubernetes cluster, and they can be spinning up replicas on their own for their development work. And then what happens when it goes to production? It's exactly the same as the way they spun it up in development, because it's exactly at the abstraction level we wanted to be working at. Do you get that point right there? That's a big takeaway here for me. As a developer, I would love if this was available to me. Okay. Okay, we got 15 minutes. Next, I'm going to show some other basic things, and we'll see as we get close. I may have to say, oh, you want to see how much it takes to add another replica? Is that important? Yeah? Okay, we got one yes, and I give brave people, basically people who answer, the chance to rule the whole class. So I'm going to scale it up. I say add another replica. Oh, actually, no, I think I'm scaling down. I think I did the wrong command. Let's see. No, I'm scaling up. I'm scaling up. So if I go here, there's now 3 of them. And again, we're acting at the level of automation we want. That already I didn't have to make a new container. It's pulling actually from the exact same Docker cache, so this should be relatively quick. Like if you think about how long it takes up to stand up and configure and do all that stuff, this is instantaneous compared to that. And it already knows how to read from the master, and it's going to start replicating. Is it load balance? So, excellent question again, my brave friend. If I go to services, this is how the whole thing works. We have cluster 1. This is the master service. Cluster 1 replica. All those replicas are, if I go here now to cluster 1 replica, can you trust me that I'm saying cluster 1 replica in the back? I know that's small, but we're going to lose font size. We're going to lose this functionality. If I look down here, it says which pods are actually being routed to by this service. It's all 3 of our replica pods. How many networking switches did I have to touch? How many configuration files did I have to touch? How happy are all of your sysadmins that you didn't touch any of those networking files or hardware? Right? Because this is operating at the level they don't want you touching. And the other important thing here, and I'm going to show this to you again in a minute, when we go to services again, let's go back. I want to show you this is how the master works. There's nothing actually in the master pod that says it's a master. The only thing that says it's a master is that it's the pod. Remember, it's the one with all the 6s in it. All right? It's got the sign of the beast in this one. All right? Because we're going to kill this one in a minute. Oh, I'm not going to on this cluster. I'm going to do a different cluster. I did not set up auto failover on this one. This is one for a DBA who doesn't trust the world. and doesn't want to do auto failover. Like if it dies, I want to manually fail it over. I'm going to spin up a cluster that has auto. Time check. All right, I was going to show you how to make a PG backrest backup. I'm going to skip that. It's really simple, so I'm not going to show it. I'm going to instead show how to do a PG. I'm going to do something, again, for the devs in the room, because we're a minority at this show, and I like supporting minorities. We're going to do a PG base backup. We're going to then use that backup to spin up a new cluster. So an example of why this would be great for you, DBAs, take a snapshot of your database with a small set of data in it, but real data. Spin up every new developer cluster using that snapshot of data right out of the box. Not some dummy test it, or in your automated testing scenarios. It's already got the data in it. So, first things first, I'll eat your brains. Then, first thing first I'm going to do is make a backup of that cluster we just made. Okay, so that is saying create a backup job of type PG base backup of cluster 1 in the namespace PostgresOpen. Good? Okay, so I can then do this, PGO. Now you get to see me put in typos, and you'll know why. PGO show backup cluster 1 -n PostgresOpen. See? So it has, oh, I know why. Because I have to say, see, this is why you want me to actually do backup -type. Because you can have multiple backups of the same cluster. You could have a backrest one, a base backup one, PG dump, PG base backup. There we go. So it's telling you which PVC it wrote to. There's all I backed up my database. Again, really nice and easy. One command, all done. I'm not going to show backup and restore. You can do it. There's other videos on the web of us doing it with this kind of stuff. But I'm going to do the more complicated thing. So what I've actually done is I backed up and I wrote data to a PVC. Everybody remember what a PVC was? It's a claim to some persistent disk somewhere out in the cloud. All right. Now, my next command is I'm going to restore. Let me paste the command in. It'll be quick, but I like doing commands first. I'm going to restore. And here's the interesting part. I'm restoring base backup. I'm actually restoring to a PVC, not to another cluster, but to a piece of disk. And I'm calling that piece of disk cluster 2. Make sense? I didn't get rid of it. No, we don't have to pretend. I don't live in that world. I'm going to call this the boss cluster. Yeah. And way to deliver snark. Who gave the snark? That was some good snark right there. Nice job. So I'm out. So if I go back to my, because I forgot to clean up from my, typical for a dad to forget to. Yeah, totally, pair programming. So if I go to storage now, you'll see that's the backup I did. Remember it said cluster 1 backup. There's a new PVC called boss cluster. And that is, I restored the data. So there's actually a Postgres database sitting in that PVC right now. Nothing talking to it, but all those files that you usually have are sitting there. So now, here comes the magic. This is why the New York Yankees tried to recruit me. All right. I mean, I'm originally from New York, so can't hold. That's not what I wanted to do. Now I have to create yet another name. So create cluster big boss. Oh, no, I have to call it. No. I have to call it boss cluster. Right? So I'm saying now create a cluster, a Postgres cluster called boss cluster. I had just the storage before, but now I'm saying bring up an instance, grab the secrets, like the username, password, all that stuff. They're stored in what's called Kubernetes secrets. Grab that from cluster. Okay, create a boss cluster, name it boss cluster. Grab the secrets from that very first cluster I made that I used the backup on. make it only have one replica and in that same namespace. Make sense? Hit enter. So what's happening now is when this cluster spins up, the name of the cluster matches the name of that PVC. And so it says, oh, is there actually all those database files there? Because if so, I'm just going to use those. And there are. And the credentials match to what's in that backup. So Bob's your uncle. Let's go. Right? It's actually, it doesn't have to do anything. It doesn't do an init. It doesn't do all of that. It just uses the data that's there. And then, let's make sure boss cluster's up. Because I don't need any more snark. So, I know. Oh, I know. So there's boss cluster. So boss cluster's up. Do you want me to wait until the replica's up so that I can show you that the data is in the replica? Or is it enough if I show you it's in the master? Wow. The brave guys trust. What about the rest of the room? Okay, as long as replications happened. But it should happen almost instantaneously, says the man who's about to get egg on his face. All right. PSQL, workshop, table, test. And there you go. No need to trust. I can verify. So again, this is great for bringing new developers on the team or wanting them to work with. You could snapshot and there's an error. There's something wrong with their code in the database, but you've moved way past that, but you have a snapshot. Boop. They can go back and test right against that. Okay? Again, and it's all with simple commands. It's not like a whole bunch of people remembering or running through a playbook or doing anything like that. It's all simple commands, and that's what Kubernetes and the operator gets you. All right. I was going to show how to add PG Bouncer. Does everybody know what PG Bouncer is? Does the app dev in the room know what PG Bouncer is? Do you? Okay, because everybody should be using load balancers. And now, since I'm an app dev by default, 5 minutes. So by moving to, since working at Crunchy and hanging around all the experts, I now believe all pooling should, in general, as a general rule, move outside of the app server and into a separate load balancer. Because I want to be able to bounce my connection pool without having to bounce my entire app server. And Bouncer does a whole bunch more than that, but that's reason enough. But I'm not going to show that. Now what I'm going to do, this is like, how many of you knew the what is it, the 1812 symphony? Ba 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 bum bum bum, and all the cannons going off. It's cannon time. All right. So what I'm doing here, I'm going to start it because it'll take a little while. I'm saying create a cluster. This is going to be called B cluster. I want Badger. Does everybody know what PG Badger is? It's a way to like have your log files and just look at them. I want Bouncer. I want autofail turned on. And then I want replica count equal to 1. Okay? Now, why this is important? What? Metrics. Oh yeah, I said something about metrics. What did I say in there? What did I do? Oh, and I turned on metrics. If we had a Prometheus and Grafana cluster running, we could have metrics automatically being put into Prometheus and Grafana out of the box. Just whoop, magic. And Bob's your uncle. I kind of never grew up with that statement, but I've kind of grown used to it. What I really want to show in this part, though, I'll show Badger if we have time, but what I want to show is failover. Okay? And I'm going to lift up my shirt just a little, but not too much because I don't want to drive all of you crazy. But there is no beeper on me. I'm going to kill the master. Oh, I have to put data in it first. Okay, so B cluster. There was some shift in the schedule, so I get a couple extra minutes. I'm just saying. Let's go into B cluster. I'm going as fast as I can. Don't hurt me. All right. Create table. I'm going to make the same data in it. Is that okay with everybody? No. No? Sarah, I'm going to inflict some imposter syndrome on you after this show. I know I learned about it. I shouldn't, but after you did that to me? No, I'm not in the... What went wrong there? Yeah, that would help, wouldn't it? Okay, made the table. Okay, so same table as before. You all trust that it's going to replicate to the replica. You good? Okay, now what I need to do is we're going to go to the master. Remember I showed you before that the only way we know it's a master is because that service is pointing to it. Right? So if I go to this pod, That's the pod ID. Now we've changed from the number of the beast to the, what's 555? I don't know. It's a fake number they always use in movies. You can call 555, blah, 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 right? All right, so it's 555 on the pod. What I'm going to do, I know I had 2 minutes, but they want to see the cannons go off. For those of you who've used containers before, how do you kill a container? What's a good way to kill a container? Actually, what's a really bad way for a container to die? That is true, but then that kills the whole server. Kill the main process, right? That will kill the container. So we do ps-auxw. So I'm going to kill the master. And the master PID is 120. So kill with extreme prejudice, 120. So automatically the terminal is disconnected because that pod is dying. Now, if we go back to the overview, you can see it's changed to light blue. Why? Because that pod is unhealthy. I don't want to route traffic to it anymore. Okay? What else is going to happen? Now it's dark blue, actually. That means I'm killing it and deleting it. So that pod is going to go away. It's gone. And now we can do the failover. Why did we wait until that was all gone? For those of you who've done failover before, where the master was still kind of running, why did we want to wait until it was all the way dead and gone? No split brain. If we had started up a replica, a new master, before it was done killing the old one, you get all sorts of bad things to happen. But this is what the operator allows us to do, is to say, make sure that's dead and gone before we actually start a new one. So you'll notice, there's B cluster, right? There's actually, now there's a new, there's one above it, right? There's too much being shown here. Wrapping up. This is the original one we had, correct? This is the new one that's already spun up, the SJOT. So it automatically spun up a new replica to keep us at 2. And if I go to the services, you're going to see, if I look at the master for a B cluster, it's now pointing to that what was originally the replica. And in typical I got to prove it fashion, if I go to the overview again, and this is the wrap up, I promise. This is the new replica. What? You guys are here for another 20 minutes. I'm going to show all the things I said I was going to show. Just kidding. Because I got to go catch a flight. Your benefit. PSQL workshop. This is in the new replica. Table test. And there it is. So you may not want to trust the machine at first. You may not want to trust all that stuff, but no beepers went off. Masters went up and down unexpectedly, not like a graceful shutdown. It wasn't like I said, Kubernetes, kill this pod or anything. It was like an uninspected, Kubernetes had no way, our operator had no way of being warned in advance that that was going to happen. But the whole system by itself said, oh, my master's dead. I need to wait. I need to kill that pod. Well, the pod would get killed on its own, but I need to not spin it back up. The default behavior for Kubernetes is if a pod goes down, bring it right back up. So don't bring it back up. When it's dead and gone, switch the service to one of the replicas, do all the changes to the replica to make it think it's the master, spin up a new replica, and plug it back into the new master. And that all happened while I was sitting here talking smack. So you may not want to trust that on all of your, but it was very nice. I didn't get called at 2 o'clock in the morning for something that was taken care of. The IP did not change. Well, the IPs of the pods don't actually matter, right? Because that's what the benefit of the services were. It always is looking for the master through that master service. So as soon as we said, hey, former replica pod, you now are getting routed by the master service, and then we probably made the master changes first, then say now you're routed by this master. It just talks automatically to that. We didn't have to change any of the IPs or anything of the pod or of the service. So this is a Kubernetes thing. Kubernetes does everything with labels and selectors. For those, if you ever dig into Kubernetes, labels and selectors are your life. There's no rewiring. You just change labels and things automatically match the new selectors, and they go.
So do the applications that use the database also have to be in Kubernetes?
No, not at all.
So as far as anything's concerned, it's just talking to a Postgres server?
Yep. As long as you can route to that. But all the standard Postgres things apply. Right, it's behind the firewall, you have to be able to route to it, blah, 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 blah. But you don't have to be, you can just be, I'm just standing up Kubernetes all day, Postgres all day long, no applications in it. I would recommend moving your applications into it just because that same thing that just happened there, if you're, like, how many of you have used Apache or had to be responsible for Apache? And how often are you rebooting your Apache server? Every night, right? So basically you can put in health checks that say when I get a 404 or anything other than a 200 for the front page, kick the Apache, and it'll automatically without you having to do anything. So there's just all sorts of benefits. And then deploying Apache becomes the same as deploying Postgres, becomes the same as deploying Cassandra, becomes the same as deploying anything you want into that cluster. But you can just do just the databases if you want. So I forgot I was being recorded. Thank you, and I'll repeat that one. The question was, by default, it assumes that replica is probably close in the same cluster. Is there a way to fail over to another zone or region? And the answer is yes, and the operator can handle that. I don't ever deal with those scenarios, but I know that we have customers who do that kind of stuff. They have it going on, and Kubernetes deals with geographic problems a little bit harder than, it's all a networking issue, right? So it's actually a Kubernetes issue, but I know we have people with two different versions of, or not two different versions, two Kubernetes in two different availability zones, let's say, and they can fail over between those. You just have to set labels. It's labels and selectors, right? There's other things that we could have also set. There's labels and, like, when I set up PGO, originally I could have said, I always want you to put the PVCs on storage that is SSD, right? Because you can attach fast disk, slow disk, and then I always want the backups on these slow spinning disks, right? And you can set that so every time you spin up a new cluster, it attaches that way to those, okay? And you can change that at runtime, but you can also just have it by default. But yes, you can do failover between regions if you want. I also know people who are just using this for hot standby, right? As a developer, I care because I want to separate my reads and writes, because I don't want to keep the master busy with a whole bunch of reads. I can just get that out of the replicas. But there's some customers we have who are just using it for hot standby. Okay, we're done. Oh, wrap up. We're not done. I did get but wrap up is quick, because I don't like slides really. Kubernetes makes your life much nicer. Hope you saw that. The crunchy PostgreSQL really helps with simplifying your life, standardizing how you do things, and automating a bunch of stuff that you probably didn't automate already. And you can use it to basically build your own in-house Postgres as a service, right? And that's it.